So let's actually look at what we have learned so far. So under electronic configuration, so we have learned about uh, three important terms. Yeah. So one is principal quantum shell, and we have subshells and atomic orbital. Okay. So by this time, I want everyone to know all this. What are these? Yeah. And do remember when we write down the electronic configuration of any elements, we fill up the electrons based on the lowest energy first. Yeah. So we fill up the electron using the lowest energy. So if I represent this, in terms of energy level, so I just put this in terms of energy level. So energy, the x-axis, can be anything. I just leave it like this. Now I know that the energy level of the first quantum shell, which is going to be the quantum shell number 1, is going to be lower than quantum shell number 2. So I'll just put principal quantum shell number 2, principal quantum shell number 3, principal quantum shell number 4. From here, what I know that I fill up principal quantum shell number 1 first, then you go to principal quantum shell number 2, principal quantum shell number 3, and then you go to principal quantum shell number 4. Why? Because I mentioned that electrons are filled up from the lowest energies first. Yeah. Now, from here, we also know that these elements, these atoms, they have subshells. So principal quantum shell, they have subshells. But for one, principal quantum shell number 1, there is only one subshell, which is going to be the 1s. So I am going to just represent this as the energy of 1s. So that is subshell. 1s is subshell. So we know for the 2, principal quantum shell number 2, there are going to be 2 subshells. And when you fill up the electrons, you fill up one of the subshells first. They are going to break into 2 subshells. They are going to have, one is going to be energy level like this, which is going to be 2s. And the energy level for the 2p is going to be higher. What does it mean? You fill up 2s first, then you fill up 2p. This is why the energy level is there. But now 1s, 2s, 2p. What are those, Haruto? 1s, 2s, and 2p. Are they principal quantum shell, subshell, or atomic orbital, Haruto?
Subshells.
Subshells, correct. So please remember 1s, 2s, 2p, they are all subshells. Similar to that, you know that the principal quantum shell, number 3, can be divided into 3. So I am going to actually do the same thing over here. So let's say like this, it is divided into 3. So I just going to just put like this. This is going to be 3s. And I'm going to just put this. This is going to be 3p. And I'm going to put this. This is going to be my 3d. And you see each of them, they have energy gaps. They have energy gaps. Now, for principal quantum shell number 4, just to make it easier to see, I'll just bring this a little bit down. This is 4. Now principal quantum shell number 4, we know that they have 4 subshells, and they are going to be divided into 4. So when they are divided into 4, I will use a different color so that you can see clearly. Now when they are divided into 4, you can see they will divide. When they divide into 4, you will have something like this. This is 4S, 4P, 4D, and 4F. Okay. Now, I just want you guys to notice about this. Yeah. So, Kalista, what can you notice with this particular diagram, the part that I actually highlighted over there, compared to the other energy levels?
3D and 4S is overlapping and 4S is under 3D.
Yes, okay. You see, in the whatever these subshells that I've drawn, okay, all of them, the subshells are higher. Okay, the energy level is higher. But there is an overlap when it comes to the principal quantum shell number 4, where the subshell of 4S is slightly lower energy than 3D. So you can actually assume that they have almost similar energy level. So they will fill up, okay, the electrons will fill up from 4S first before they go to 3D. Yeah, this is the better explanation, okay, when it comes to when I draw this 1S, okay, 2S, 2P, 3S, 3P, 3D, okay, and then 4S, 4P, 4D, and 4F, and so on, 5S, and so on. Okay, so when I want to fill up the electron, I will fill up 1S first, okay, then I will fill up 2S, okay, then I will fill up 2P followed by 3S, then I will fill up 3P followed by 4S, not 3D. Now, you can see after 3P is 4S, after 3P is 4S, then only you fill up 3D, 4P, and 5S. So this way of writing or trying to figure out is just a way for you to memorize, okay, just to make your life easier, okay. But by this time already, yeah, you don't even need to draw what I am drawing over here, because you should know that, okay, 4S gets filled up first, okay, before, okay, 3D. The reason is because of the the energy level, yeah, because of the overlapping, okay, where, okay, 4S subshells will have a lower energy level compared to 3D subshells. You see the terms that I'm using, yeah, I'm not just simply using 4S 3D, no, I'm using 4S subshells, 3D subshells. Learn how to actually apply the terms, okay, in your answers, yeah. So that is actually the explanation about, okay, why certain things are going to be filled up first, why certain things are not filled up first. Yeah. For example, okay, if we are talking about scandium, okay, scandium is going to be 21. Okay, so let's actually try to write down, okay, the electronic configuration of scandium. Okay, scandium, you write down 1s2. Okay, you write down 1s2. Okay, then after that, okay, scandium is going to be, you have 2s2, 2p6. That's already 10. Yeah. Then you have 3s2, 3p6. Okay, don't go to 3d10. Okay, don't do that. Okay, so you fill up, okay, 4s2. So now this is going to be 10. This is going to be 10. I need one more. Okay, that one more comes from 3D, which is 3D1. Okay, this is how you write the electronic configuration for scandium. Now, I also mentioned that, okay, you can also write down in terms of shorthand rule. Now, shorthand rule is going to be applied when you have, okay, the group 18, okay, not helium. Okay, the other day we already mentioned about this. Yeah, we don't use helium, but you can actually use neon, argon, and so on, okay, to write down your shorthand configuration. The shorthand configuration configuration in this case is 18. Yeah, so because 21, 18 is argon. Yeah, so I can actually use argon's configuration, which is I know up to here is argon. Yeah, so I write down argon. Okay, then bracket. I put 4s2 3d1. This one no problem. Okay, because this is quite common. Okay, but I want you to focus on these two exceptions. Okay, so they are going to be for chromium. Okay, they're going to be for chromium, and they are going to be for copper. Okay, so let's actually look at chromium. Let's actually look at copper. Chromium is 24. Okay, copper is 29. Okay, so let's actually look at how we write the electronic configuration. Just to save time, okay, I will use argon. Yeah, argon is 18, so I just put argon. Okay, so after 18, there are 6 more electrons to make it 24. So I will always start with what? Because I think over time you will actually understand it will start from 4s2, yeah, after argon. So I will start with 4s2 here. Okay, and then it should be 3d. Okay, so I have 18. 18 plus 2 is 20. So I need another 4, 3d4. Now for chromium, okay, if I write down in terms of orbitals, okay, so I write down in terms of orbitals, I draw the boxes, okay, and then D have 5 boxes, okay. So I draw 5 boxes over here. I will represent, okay, using the arrows, okay, here, and then 3d4. Okay, I put the arrows like this. Now, in this case, okay, this electronic configuration is not stable. Okay, why? Because, okay, 4s and 3d, because they are almost at the same energy level, the electrons from 4s can go to 3d. Okay, so in this case, okay, because there will be a repulsion, okay, over here, the electrons tend to move so that you are going to occupy 1 electron, okay, in each orbital. Okay, so to form partially filled orbitals, okay, or partially filled subshells. Okay, so I will actually erase, okay, this electron, because this electron now is going to go here. So this is not the good way or not the accurate way to write for chromium. It should be Ar, okay, and then 4s1 3d5. Okay, this is going to be the exceptions for chromium. Now, we do have another exception for copper. Okay, copper is written as Ar. Okay, so Ar is going to be 18. Yeah, so you have 4s2. That's going to be 20. Okay, so 3d1. Okay, so I need 9. Yeah, 29. So 3d9. So in this case, okay, if I have like this and I want to draw the orbitals, okay, when I draw the orbitals, I will see something like this, okay. I will have 2 electrons here, okay, and I will have all these electrons, and one of it will be empty. So what happened? Because there is a repulsion and the electrons prefer, okay, the subshell to be completed. Okay, so what happens? Okay, because the 4s subshell and the 3d subshells, the energy level is almost the same. The repulsion that happens over here will repel this particular electron so that they are going to form a complete orbital or complete subshell, okay, of 3d. Okay, so this is more stable. So therefore, this is not accurate. Okay, we write it as Ar, okay, 4s1 3d10. This is the correct one. Okay, so please take note. Okay, for your syllabus, you need to know about this chromium and you need to know about copper and why this thing is happening. Okay, this is very, very important. Okay, so now, okay, I just want